In this question, we're asked to calculate the pressure, ultimately the atmospheric pressure, at a height of 10 kilometers above the surface. But we're given this extra bit of information. We're told that the atmosphere from sea level up to 11 kilometers high has a constant lapse rate, is a constant lapse rate layer, and we can assume a lapse rate of basically 6.5 degrees Kelvin per kilometer. Okay. And we're also told the pressure at sea level and the temperature at sea level and the specific gas constant. So the way that we solve this is, because we're in the constant lapse rate layer, we need to use the appropriate equations. Okay, so we can do this in two steps, or we could just substitute this formula into here and work it out in one go. But we were actually told to find the temperature first. So the temperature at the particular altitude is equal to the temperature at sea level minus the lapse rate times the change in altitude. So if we work that out, we get a temperature of 223 Kelvin. Always remember to work in Kelvin for these types of problems. We then use that temperature in this equation, put in the values at sea level, so the pressure at sea level, temperature at sea level, and so on. And then we work out a value of around 0.264 bar. And if we compare that to the value from Rogers and Mayhew, then we see that we're much closer, probably just a slight error in there. So by including the change in temperature with altitude, we've now worked out the correct pressure.